Okay, in the last video, we're going to be taking a look at these two systems of equations. So before I do anything, can you see that this first equation is not written in standard form? So I want to get this in standard form, so I'm actually going to start by rewriting these two equations. So the first one's going to be, that looks like a Z. The first one is going to be 7x squared minus 3y squared equals, we're going to move that 5 over, and that's going to become negative 5. And the other system is going to be 3x squared plus 5y squared is equal to 12. Before we get started talking about how to solve these, I just want to take a minute and introduce to you that these are not functions. When you see an x squared plus a y squared, that is going to be some sort of, basically anytime you see an x squared and a y squared, we're going to start talking about a concept called a conic section. This bottom equation down here, 3x squared plus 5y squared, that is actually an equation of a circle. And this top one, when you have an x squared minus a y squared, you're going to see something called a hyperbola. I'm going to show you a graph of these just so you can see what we're taking a look at here. So when you look at a graph of this, this is the graph that we're taking a look at, and you can see that the red graph, sorry, let me bring this into focus for you. Okay, so the red graph, this is what we call a hyperbola. You can see it kind of looks like two parabolas, one stacked on top of each other. Again, this is not a function because it wouldn't pass the vertical line test. This one right here, 3x squared plus 5y squared equals 12, that gives us this shape right here. It looks circular. We're not really sure whether it is a circle. Actually, we know it's not a circle because these are not, this radius is 2, that radius is not 2, but it is a round shape. We can see how many times do these two shapes intersect. Again, this is the crux of any systems of equations. It doesn't matter whether we're graphing lines or parabolas or circles or hyperbolas. We are looking for where these intersect, and I can see that there are 4 points of intersection here. So I should be having 4 solutions. Sounds like a little bit of work, but we can make this happen. So what are we going to do here? I'm going to use the technique that I think we always use when you see a bunch of numbers in front of our x squared and y squared terms, and that is we are going to follow the elimination method. So to do eliminations, I think we're going to try to eliminate these y's because these are opposite signs. So I'm going to multiply the top equation through by 5 to make that a negative 15y squared, and I'm going to multiply the bottom one by 3 to make that a positive 15y squared. So when we multiply that through, we get 35x squared minus 15y squared minus 25. And when we multiply the bottom equation through, we get 9x squared plus 15y squared equals 3 times 12 is 36. All right, so now that we have gotten those to match up, we are going to line these up and we are going to add them. So 35x squared plus 9x squared is 44x squared. Negative 15y squared, positive 15y squared, those are going to eliminate, and that's going to leave us equal to negative 25 plus 36 is 11. Now I am going to take and divide 44 on both sides here, and that is going to give me x squared is equal to 11 divided by 44 is 1/4. We are not done yet because this is squared, so we are going to take the square root of x squared. Now remember, that's going to divide us into 2 separate answers here. We're going to get x is equal to the positive square root of 1/4, and x is equal to the negative square root of 1/4. And the square root of 1/4, well, square root of 1 is 1, square root of 4 is 2, so this simplifies to 1/2 and negative 1/2. So I know my x values are going to be equal to positive 1/2 and negative 1/2. This is similar to the last problem we did. Now to get the y values, I need to pick one of these equations and plug these values in. So I'm just going to use this original bottom equation right here. So we're going to be working with 3x squared plus 5y squared equals 12. And we're going to start by plugging in. We have 2 conditions. We have x is equal to 1/2 and we have x is equal to negative 1/2. So let's figure out what those values equal. Let's plug 1/2 in for x here. So it's going to be 3 times 1/2 squared plus 5y squared equals 12. And 1/2 squared is 1/4, right? So this is going to be 3 times 1/4 plus 5y squared equals 12. 3 times 1/4, 3/4 plus 5y squared equals 12. Let's move that 3/4 over, minus 3/4. 12 minus 3/4 is, I think it's 5y squared equals, this is going to be 45/4. So 45/4, when we divide both sides by we divide both sides by 5, and we get y squared is equal to 9/4. All right, so scroll down just a tad here. Okay, we have to take the square root of y squared. So we're going to take the square root of y squared. And again, that's going to break us up into two solutions. We're going to get x is equal to the positive square root of 9/4, and x is equal to the negative square root of 9/4. And we know 9/4 simplifies into square root of 9/4 simplifies into the 3/2. So we get positive 3/2 and negative 3/2. So when my solution was 1/2, I got two answers. I have 1/2 positive 3/2 and 1/2 negative 3/2. If I take a look at the graph, I bet those are these answers right here. You see positive 0.5, these are those two solutions. And now we're going to plug that in to find the negative solutions. And I think we're going to probably see that something really similar is going to happen here. So when we plug in negative 1/2 squared is equal, negative 1/2 squared plus 5y squared equals 12. Negative 1/2 squared is also 1/4 plus 5y squared equals 12. And I take a look, hey look, this is the exact same equation I got over here. So you can go through the whole rigmarole of working all this stuff out, but you're going to end up getting the same y values. So you're going to get, this should say y is equal to over here. So make sure you change that. We're going to work this out, and after we get to the end, we're going to get y is equal to 3/2 and y is equal to negative 3/2. Again, we're solving the exact same equation I did right here, so we're pretty sure that those are going to be the answers. So here we have when x was negative 1/2, I got y is equal to 3/2, and when x was negative 1/2, I also got y is negative 3/2. And these are going to be our four solutions. And when we go take a look at the graph, we can see that our graph intersects at 4 points. We found those 4 points of intersection. Those are our solutions.